This is a screen recording to capture information about how to set up the networking of a Linux box. What you're seeing here is a virtual machine, and I'm logging in as root because most of the commands that you need to use to deal with networking requires that you have root access to the system. Alright, so now that we have root access, let's go over a few things, all the necessary ingredients to use networking. The first part is the physical NIC the network interface card has to be here. There are several ways to double check and see if the system correctly recognizes your hardware or not. The first step is to use DMESG and pipe it through less so that we can search and also page up and page down. And over here, these are bootstrap messages. When the system starts up, these are the messages generated by the kernel. And throughout the bootstrap sequence, you should be able to find the networking. If the system was able to recognize the network card, it should indicate it here, and you can look for network. Okay. And right here we find out our network, and it's right here. ETH0 is the card. It's a Realtek 8139 chipset, and it is getting recognized. So that's the first thing you have to do, is to see if there's a message in DMESG to indicate that the hardware is recognized. Now that we know that this card is in the system, the next thing we need to do is to see if the correct software driver is installed. To do that, you have to run the command called lsmod, and once again we want to pipe it through less so that we can do some search. We know that the chipset has the code 8139 in this case, so we're looking for that name. You can see that 8139TOO is loaded, so that's basically the software driver responsible for that network card. So with the network card recognized, the network card software driver loaded, that means the operating system should be able to talk to the network card. And one thing you can do right now is to check with ifconfig and see whether the network card ETH0 is up and running, and the fact is it is up and running. Now it is ETH0 in this case because it is the first card recognized. There is one particular file that will control how a network card, or I should say how the MAC address of a network card is associated with ETH0, ETH1, ETH2, and so on. So let's go ahead and take a look at that file. That file is located in /etc/udev user device /rules.d/70-persistent-net.rules. This is the name of the file. And you can see here that I only have one entry because I have only been using one NIC with this particular virtual server. On the other hand, if the operating system has been exposed to multiple NIC cards, then you should find multiple entries. With these multiple entries, you can see that the hardware address is 525400123456 in this case, and it is associated with the name ETH0. If you have multiple NIC, or if the operating system has been associated with multiple NICs, then you will see multiple entries like these, and the name will not all be ETH0. It will be ETH0, ETH1, ETH2, and so on. Now this file can be edited. In other words, if you don't want this NIC to be called ETH0, you can change it to ETH1, ETH2, and so on. But doing that is dangerous because there are other files that depend on ETH0 as the name of the interface, of the network interface, and I'll go show you those files right away. Now, on the other hand, if you do need to change these entries, you can change the entries, save the file, and then the next thing you need to do is to make the file effective. To make that effective, you have to restart the script to start udev, and that's /etc/init.d/udev, and then just type restart. What this will do is it will stop the current configuration. It will stop the current system configuration, and we'll restart it using the text file that you have edited already. After you do that, just to make sure that the system will use the new names that you have defined in that particular file, what you need to do is to unload the software driver and then reload it. In this case, our driver is 8139CP. So what we can do now is to say rmmod remove module 8139CP. And once you have done that, if you do ifconfig, you can see that that NIC is gone because we have just unloaded the software driver for that NIC. And then what you can do is to say modprobe again, modprobe, which will reload the software driver. When you do that, the system should use the new name that you have entered in the rules file, and if you rename the interface to eth1, it should be now known as eth1. Now sometimes the system will automatically bring up, in this case let's take a look at ifconfig again, and the system automatically brings up the interface and have an IP address associated with it. That's because of another files. Okay, so right now we have only worked up to the software driver and the naming of the interface, which is eth0. But once you have the interface up and running, the question is, how are you going to get the IP address and also the net mask and the broadcast address and all the other useful configuration data with that interface? That turns out to be in the file called /etc/network/interfaces. This file contains the information that the system needs in order to configure a particular network interface. Right here we have allow hot block eth0. So that basically means that eth0 doesn't have to be there all the time. We can unplug the NIC and then replug it in, and when it is replugged in, it will automatically recognize it and run the necessary steps to connect it to the network. The second part is iFace, which is interface eth0, so where the rest applies to eth0. iNet is internet, and DHCP means that we are not using static IP. When eth0 is connected, it will automatically start up a client, a DHCP client, in order to get its IP address. This is okay and desirable for most desktop computers, but for a server, this may not be what you want to do. If this is not what you want to do with a server, what you need to do is to understand how to use the basic features of interfaces. Interfaces is very flexible. You can do a lot of things. But when you're running a server, for the most part, you will just be needing to configure, let me find that part here. Okay, the static method, which means you want to change it to use static IP. And when you want to change a network interface to use a static IP, then you need to supply several pieces of information. The first one is the address, which is the IP address. The IP address has to be unique to each interface. If you have multiple interfaces, they all have to have unique or different IP addresses. The net mask is something that your network administrator should provide. It specifies which part of an address is the network address and which part is the node address. The next one is called broadcast. It is an IP address where if a node transmits anything or direct anything to that particular IP address, it is actually directed to the entire subnet. The next one is the network address. The network address is closely related to the address and the net mask itself. With these two, you can always derive the network address itself. So for later kernels, it is no longer needed. You can always specify it, but it is no longer needed. Metric is something that you do not need to use most of the time. Gateway is important because what you need to do is to figure out in the subnet which node is a router to direct traffic to outside of the subnet. So that is important. Point-to-point is only useful when you're using PPP, so we're not going to do that. Media, hardware address, which is a MAC address, and MTU are typically the default values will work just fine. Okay, so right now let's go ahead and change this or give it a try. And what we'll do is we'll run ifconfig right now. You can see that the internet address or the IP address of this machine is 2.16. The broadcast address is 10.02.255. The net mask is 255.255.255.0. So we can go ahead and edit interfaces to input all this data. Let's go ahead and give it a try. Oh. And what we'll do is we'll say iFace auto eth1. So we're defining a new network interface, and I'll explain why I use eth1 because this will be a good test for that too. We use interface eth1. We specify that to be an IP network interface, and we want to use static here. Now after that we have to spell out all the parameters, which can start with the address. So we'll make it 10.0.2.16, not 15, so we'll select a different one this time. We'll specify the net mask to be 255.255.255.0. We will specify the gateway. Unfortunately, I cannot remember what the gateway was, so we'll go ahead and find that out. To find out what the gateway is, I do not believe ipconfig will tell you what the gateway is, and it did not tell you what the gateway is. Another command would give you the current gateway of the system is called route, and it shows you that the gateway of this system is 10.0.2.2. So we'll go ahead and continue with our editing of the interfaces file and specify the gateway to be 10.0.2.2. The broadcast address should also be entered here. That usually does not need to be entered, but it doesn't hurt to get it entered, and in this case it will be 10.0.2.255. And I believe that's all the information that we need to enter. Let's go ahead and check with the man page just to be sure. The static method, we just entered address, net mask, broadcast. Network is not required because once you have address and net mask, network is automatically it can be computed. We specify gateway, and those are all the parameters that we need. So we are now ready to use eth1, but we don't really have eth1 as a network interface. So there are a few other things that we have to do right now to fake that we have eth1 as a network interface. One thing we'll do is we'll go ahead and bring down eth0 first. And now we can see that interface 0 is no longer active. So that's the first step we have to do. And then we'll go ahead and change the udev rules.d/70-persistent-net.rules file. And what we'll do is we'll change this entry and say that, oh, by the way, a network card with that hardware address is going to be called eth1. But remember, you can change the text file all you want, but the system has already read the previous version of this configuration file, and it will keep using eth0 to correspond to that MAC address unless we perform this step here to force the system to reread the configuration file. Okay, and then the next step is to remove the driver I think it is 8139CP, and then use mod probe to reload it. And let's go ahead and read the MESG to make sure. And you can see that it is now renamed to ETH1. So the renaming has been successful. Now the question is, do we bring up that network interface automatically? We can take a look at ifconfig. It's not brought up automatically. Well, the reason why it's not brought up automatically is because, let me show you that. It's because, see, with ETH0 we have allow hot plug, but with ETH1 we did not specify hot plug. So that means, when it is connected, we do not configure it automatically. But that's fine. Even if we don't configure it automatically, we can always force it to be brought up. So we say interface up ETH1 in this case, and then we use ifconfig to look at the interfaces again, and now we have ETH1. It has the same MAC address as before because the hardware is actually the same as ETH0 from before, but this time we are using the interfaces file and we are using the static IP method to make it correspond to 10.0.2.16. Now, if you configure a server or a computer using static IP the first time, it probably would not know which DNS server to use. In this case, because I have been using this machine already, so I think it might already have an entry for the DNS servers. And VI. The file that contains the name server definitions is /etc/resolve resolv without the e.conf, and it already has an entry, and this is a local entry. Basically, the router of this machine is also doubling as a name server. But that doesn't have to be the case, because what we can do is to use, I'll just comment this out, and instead we'll use the public DNS server of Google, which is 8888, and the backup of that is 8844. Okay. Now we can check whether it is working or not, so we can try to ping Google, because when you say ping google.com, it has to resolve the domain name into an IP address first, and that means it has to contact a DNS server. And as you can see, the ping was not successful because I'm running this inside a virtual machine, and when we are running this inside the virtual machine, ping messages which are not TCP/IP packets cannot go through. But we know that it is successful because it can actually resolve google.com into its IP address. So that means at this point, this machine is all set up. We have, as a server, we are not expecting the IP address or other configuration of the internet protocol to change. So this machine is ready to go. So I hope you find this video clip useful, and you can certainly use this to help you diagnose problems. Just remember several things. One, use the MESG to see if the system could even see your network card. If the system could see your network card, then you can proceed to use LSMOD to list the modules to see if the proper software driver is loaded. I know this part can be confusing because you have to know the name of the software driver corresponding to the network card that you're using. You can find out those modules inside a particular folder. You can go to lib/, let's do a CD there, lib modules, the kernel name, and over here you can go to net, and inside here we have nope, I got it wrong. Let's see, it's under drivers, and then we go to net, and this is where we put all the hardware specific software driver for NICs. the names usually would imply what type of device we're dealing with. For instance, our current network card is a 8139. E1000 is a particular model from Intel, and so on and so forth. So with this list here, and you can see this, the path to that particular folder is lib, modules, the kernel version, kernel, drivers, net. So you can see that these are all driver names. It usually does not hurt if you try to mod probe and load a driver where the NIC does not exist. I can do it. I can show you here. So I can say mod probe E1000E, and we don't have an E1000E Ethernet controller in the system, and you can run mod probe. It's just that it's not going to do anything because the driver could not find the software driver could not find the hardware, and it doesn't do any harm. So this is the second step. After the second step, if you know that the correct driver has been loaded, then you have to check the other file. You have to check the file /etc/udev/70-persistent rules. Okay, sorry, I got it wrong. rules.d/70-persistent-net.rules. So you have to look at this file. I keep forgetting that I don't have vim, I have vi. And this is one place you can check to see whether the MAC address of that device is mapped to the correct name that you want to use for that particular network interface. You don't have to use ETH0, okay, but the default is to use ETH0 as the first network card. You can network interface. You can start with ETH1, just like what I have just done. Okay, if that is working fine, then you can check ifconfig to see if the network interface is already up and running. If it is not up and running, you can use ifup and then followed by the name of the interface to force that interface to bring up. That is necessary sometimes, and of course the next thing you want to check is network/interfaces, because that file tells the system how do we bring up that particular interface, and in this case ETH1 is using static IP, and if I use ETH0 it's going to be DHCP. But we don't really have a ETH0 anymore because I changed that entry in that file. Okay, so I hope you find this video clip useful when you need to diagnose problems with networking in Linux. Thanks for watching.